This lecture is going to go over ionic naming, so we're just continuing with some more specific types of ionic naming. So you'll want to have out your ion packet, and then you can also have a periodic table out as well. So we're going to be looking at another type of binary ionic compounds. So everything that you've already done with binary is going to apply here, but this is when we're going to look at those ions that have multiple charges. So you should remember doing these when we took ion quizzes. So just to recall, some things form more than one ion, so they have more than one charge. This is when we're going to use the Roman numerals. So now those Roman numerals that we're used to using on our ion quizzes are going to start coming into play in our ionic compounds. So the first thing that you're going to have to do is determine if the metal is one that requires a Roman numeral. And if it does, you're going to need to determine the charge, and you have to include that in the name. Now, all of the ones that you get on this practice sheet are going to require Roman numeral, so you can get in the habit just by doing those with the Roman numeral. But when you get to the end in your level quiz, it's not going to be identified for you. You're going to have to be able to remember what requires a Roman numeral and what does not. So just kind of get in the habit of remembering those ones that need them and which ones do not need those Roman numerals. So here's our first example, is iron 3 oxide. So we're going to go through the same routine that we have done with the other ionic naming when we're going to write out the actual formula for the compound. You want to write your charges above your above the names. So it tells us here what the charge of this iron is. It's iron 3. So that's going to be a positive 3, because remember that cation always comes first. And oxide has a negative 2 charge. So same thing that we've done before. We want to cross our charges to make them cancel. So if I look at my 2 is going to go here. My 3 goes here. So I'm going to have Fe2O3. All right. Taking a look at our next one, copper 1 phosphide. So same thing. Remember, we're just writing those charges out above. Plus 1. Phosphide is minus 3. So then if we just cross our charges, Cu3P. Remember, we don't need anything after it if it's a 1. So I'm going to give you 2 here. Go ahead and pause the video, write these down, give them a shot, try them out, and then come back and check your answers. All right, so take a look at the answers that I have written here and just double check what you did. So remember that cobalt has a plus 2 charge, sulfide has a minus 2. So really they cancel out to start with, so we don't need to cross anything. So we are left with COS. Manganese has a plus 7 charge, fluoride has a minus 1. If I cross them, that 7 is going to go to the fluoride, and the Mn is going to have a 1 next to it. Alright, so now we're going to go the opposite direction. This is the way that can be a little bit more tricky, and this is when you're going to have to remember, does it need that Roman numeral or not, when we start to mix them all together. So, what we can do to see what those charges are is we can uncross our charges. So the 2 goes back to the O, the 3 goes back to the V. So remember, cation's always first. So this means that vanadium is going to have a plus 3 charge, and we know that oxide is going to have a minus 2. So now we just go to the naming part. So we're left with vanadium. Sorry, my handwriting on the screen's a little bad there. What charge did it have? It had a 3. So vanadium 3. Oxide. Remember, if we just leave it like this, vanadium oxide, that is not correct. Vanadium needs a Roman numeral, so we have to include our Roman numeral of a 3 there. So let's take a look at another one. So first thing we're going to do is uncross our charges. So the 3 goes to the N. If there's nothing there, remember that's a 1, goes to my copper. So that Cu had a +1, N -3. So now we just name. So this is copper 1, and N is nitrogen, but remember my ending on my anions changes to nitride. So copper 1 nitride. Again, have to have these charges. Copper can be more than one charge. We have to indicate which one it is. All right, take a look, pause, and try these on your own and see how you do. All right, so take a look at the first one here. So if I uncross my charges, that 2 is going to go back to the titanium. The 3 goes back to the phosphide, so I'm left with titanium 2 phosphide. Now, just as we've been saying on all of the rest of the naming, if you do not have exactly what I have written here, it is incorrect. So if you have something different than titanium, maybe you put tin, that's wrong. If you have something different than the charge that I have here, that's wrong. If you put phosphorus instead of phosphide, that's wrong. Okay? You have to make sure that you're paying attention to all of these little details. So it comes back to knowing your elements, knowing your cations and your anions, knowing charges. So all of those pieces are now starting to fit together. So this one, I actually want to do this one with you. So if you look at it, if we uncross them, we're likely to think that it's 1 and 1, right? Because there's no subscript under each one of these. So we would say chromium 1 oxide. But what we have to remember is that oxide has a charge of -2. So oxide's charge is never going to change. Now, if I have my charges cancel, that means that this Cr must have a +2 charge. Okay, so it's not chromium 1 here, it's going to be chromium 2 because of the charge on this oxygen. So I'm left with chromium 2 oxide. So one thing that I encourage you to start with is always start with that anion and make sure that the charge that uncrossed from there is correct. Because then you would have noticed quickly, oh, I know that oxygen's -2, so that means that chromium must be +2 to balance out. All right, so the last one I want to take a look at here is kind of a little bit of an exception. You're going to use some of your math skills in this one. So we have tin, IV is 4, oxide. So this is a +4, this is a -2. We know the oxide's -2. So then I'm just going to do what we naturally have been doing, and I'm crossing my charges. So what I should be left with is, oh, we should write that out as a symbol, SN2O4. But remember, what we want to be left with is numbers in their lowest ratio. So I can divide each of these out by 2 to be left with SNO2. Okay, so my charges still cancel in this situation. Now, this is not technically wrong because your values do cancel out, but this is the actual formula. Okay, so this is what I'm looking for with you there. So just something to keep yourself aware of. Can my values be reduced anymore? All right, take a look at your practice sheets. Remember that whole sheet is going to require Roman numerals, so just make sure that you are including those in there, but also be aware that you're going to eventually see mixtures of ones that need them and don't. So you just want to kind of make sure that you're getting yourself used to, again, which ones require Roman numerals and which ones do not.